Okay. Today what I'm going to do is I'm going to go through each question from Unit 3 quiz. I'm going to explain how to get the answers. I'm going to talk about common mistakes. For those of you who did not do very well or you want a higher grade on the Unit 3 quiz, when you're done watching this, you can take the second version of the quiz. It's very similar to this, so hopefully you can learn from your mistakes and go back and get a better grade. So let's get started. On number 1, it says graph each of the following functions. Use the given domain for the table. So number 1 looks like this. Y equals 2 to the x power. Domain is negative 2 less than or equal to x less than or equal to 3. So all we were trying to do was to give you a hint of what to put in the table of values. So what we wanted you to put in the table of values was from negative 2 to 3 whole numbers. So negative 2, negative 1, 0, 1, 2, 3. Now this is where you should have gotten out your calculator. You should have gone to the y equals button. You should have typed in 2. The caret key, which looks like this, it's above the division key, and then the x, t, theta, n, which is right next to the alpha key. And then you should have done graph to look at your graph and to see where your boundary was. In this case, the boundary was the x-axis, or where y equals 0. Okay? And then you should have looked at your table. To find the table, you hit second, graph. And that'll tell you your table of values. From there, you can just fill in your table with the appropriate numbers. 0.25, 0.5, 1, 2, 4, and 8. And that was half the problem, is to fill in those equations. Now, if you don't have a graphing calculator at home, you need to let your teacher know, and we can help you find it. There are apps on the iPhones, there are apps on the Androids, and there's also computer programs that mimic the graphing calculator. Okay, so now that you have that information in, we're going to now graph it. And here's places where you could have lost points. So first of all, you should have put the points on there. Now, they didn't have to be perfect, but here's a big key about this. We did not cross the x-axis. The range of this is y is greater than 0. So negative 2 and 0.25 should be right about there. And then we slowly come up. And I'm just putting in the numbers that are in the table. 4, and then 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, when you connect this, you need to skim along the boundary without crossing it. If you crossed it, you probably lost a point. Okay? So that's how you got full credit for number 1. Number 2 is the exact same thing. Number 2 is y equals 3, parenthesis, 1/2, close parenthesis, raised to the x power. The domain is still negative 2 to positive 3. So that's what goes in your table. Now, I just went step by step on how to use your graphing calculator for this, so I'm not going to do it a second time. You can go back and listen to it again if you want to. Negative 2, negative 1, 0, 1, 2, 3. Once you put this into your graphing calculator, if you've forgotten, the way to do a fraction is to do 1 divide 2 and make sure you use the parentheses. When you did that, you should have gotten 12, 6, 3, 1.5, 0.75, and 0.375. If you got that incorrect, you entered it wrong into your calculator. It's not your calculator's fault. You need to go back and look at y equals and see if you plugged it in correctly. If you're still having trouble with it, that's when you contact your teacher and see if we can help you with it. Okay, same thing graphing this one. It's going to skim along the x-axis without ever crossing it. Now, negative 2 and 12, I can't quite fit on mine. 2, 3, 4, 5, 6. This goes up pretty quick. 0, 3. It actually comes down really quick. 1 and 1.5. 2 and 0.75. And then 3 and very close. Again, we start up very high, comes down, and then it's skimming along the x-axis. It better not cross the x-axis, or that's where you could lose a point. So that's for number 1 and 2. As you can see, they were each 6 points. And so you could have lost points for not graphing. If you didn't turn in a graph, you lost 3 points. If you don't know how to turn in a graph, you need to contact myself or your own teacher so you can learn how to take pictures and do that. Okay, now let's go on to number 3. And then you probably all saw that I don't know how to count, and there is no number 3. There is no number 3. I miscounted. So let's go on to number 4. Number 4 says, determine whether each sequence is geometric, arithmetic, or neither. If arithmetic, identify the common difference. If geometric, identify the common ratios. Some of you lost points here for not reading directions. Okay, let's start with number 4. It was 3, 6, 12, 24, and 48. Let's say you didn't see the pattern immediately. There's a couple things you could say here. You could say, well, this was going up very quickly, and so this is not arithmetic. Let's see if it's geometric. And as I taught you in our videos, you should take the second term, which is 6, divide by the first term, which is 3, and see if by multiplying by 2 each time, if that's the answer. And in this case, that's what you did. Some of you just saw that. Some of you wrote geometric, and that was all you did. You were asked to give the common difference or the common ratio once you had identified it. So here you needed to say times by 2, or even over here I looked for it, that you were timesing by 2 here. Okay, somewhere I needed to find that common ratio. All right, some of you just got it wrong. You need to go back and check your work. These are open notebook, open Google. You could talk to people. Just getting it wrong is probably not the best idea. You need to go back and go over this stuff. The answer key. Okay, number 5 was 7, 15, 23, 31. Not going up very quickly. So I check. I take the second term, 15, and I minus the first term, 7. And when I did that, I got 8. And then I just checked. Is it a plus 8 each time? If it is, which it was, it's arithmetic. And again, you needed to put plus 8 there. Okay, so you could have lost points for not reading directions. Number 6 and 7 says find the geometric means in each sequence. It was very obvious that some of you didn't even watch the video for this. You came up with some very strange numbers and you didn't do anything that looked like what I taught you. If you're not watching the videos, you're not doing your job. Okay, so number 6 was, I had mine crossed out. Let me find it on another sheet. Number 6 was 4, comma blank, comma 36. This should have been set up as a proportion, and this is the way you set it up. 4 over x equals x over negative 36. It was not negative 36, it was positive 36. Okay? Some of you, I saw that work. Some of you just made up an answer. That's not really doing your job. Okay, we cross multiply here, get x squared, and then you do 4 times 36, and 4 times 36 is 144. Now some of you immediately jumped and gave me the answer 12, which is fine, except you forgot. When you square root a number, and here's what we needed to do, you square root both sides. When you bring a square root to a number, you have to take into account there's 2 answers. There's a plus and minus. So the answer here was truly plus or minus 12. If you forgot the plus minus, you lost some points there. Because again, this was open notebook, open review packet. A really good way to take this would have been to have your review packet completed and correct sitting next to you as you were taking this and you were checking it, okay? Number 7 was negative 6 and negative 96. Again, negative 6 over x equals x over negative 96. This was from Unit 3, Lesson 1, Section 1. So we cross multiply and you get x squared equals negative 6 times negative 96, which gives you 576. Square root both sides. Again, that brings in 2 solutions here. And the two solutions were plus or minus 24. If you forgot the plus minus, you lost a point or two. Okay? All right. Now we go on to the word problems. There were 3 types of word problems I taught you. And some of you just made up some equations that you liked, I guess. There were 3 equations. There was a growth equation, which was y equals a parenthesis 1 plus r raised to the t. There was the decay, which is y equals a 1 plus r raised, or 1 minus r, sorry, decay. So we're taking away the rate raised to the t. And then there was compound interest. And I believe, let me make sure I get this correct from what I wrote in our notes. Compound interest was a equals p parenthesis 1 plus r over n close parentheses raised to the n times t power. Now you needed to know what each of those letters stood for, but if you forgot, you could go back and look. I gave you notes on that, and some of you I can tell didn't go back and look. You just started plugging things in, and some of you just made up your own equations. So let's look at number 8. It says determine if each problem is decay, growth, or compound interest. Use the correct equation to solve each problem. So number 8 says, since 1976, the cost of a first-class stamp has risen according to the model approximately. Oh, look, they actually give you the formula. They say cost, depending on the year, is going to go up by this formula. Okay? Now, maybe that looked confusing to you. It's really just y equals 0.16 1 plus 0.028 raised to the t. They've already told you this is a growth equation. Okay? There's the equation. You just have to fill in the values. They filled in most of the values, so you just have to identify them. In the first part, it asked you, what does the model predict the cost of a stamp will be in 2020? You don't use 2020 as the time. You need to know the difference from when this model started to now. This model started in 1976. So to figure out the time, you have to do 2020 minus 1976. When you do that, you get 44 years. That's your time. So then you go y equals 0.16, 1 plus 0.028 to the 44th power, which you use your calculator and you solve it. Now, some of you didn't round. We're talking about money here, so you should have rounded to the nearest penny. The estimate of a cost of a stamp would have been 54 cents. If you got the formula correct and you got the answer wrong, you need to check your calculator work. You did something wrong on your calculator, and so you need to figure it out. Now, part B and C were more about thinking. Part B says, in 1976, when does the model suggest was the cost of a stamp? And then explain your answers. A lot of you lost points because you didn't explain. But you have to go back to what each letter means in this formula. So let's go back to what our original one was before we put any numbers in. And if you remember, or if you actually watched it, here's what A stands for. A stands for the starting amount. And the year this model started was 1976. So all we have to do is look and see what A equaled. And in this case, A equaled 16.16. So the cost of a stamp in 1976 was 16 cents. You needed to explain that somehow. Something about A stands for the starting amount. A is where we were in 1976. That was our initial cost of a stamp. Something to that degree. You lost some points if you did not explain it. And then C says, according to the model, what is the percent increase each year? Well, the percent increase comes from our R. So in this case, we have to look at what the R was in our original formula. In our original formula, the R was 0.028. Well, that's not the rate. That's the decimal. I want the percent increase each year. Well, to change a decimal to a percent, you times by 100. And the percent increase each year was 2.8%. And then you needed to explain how you did that, somehow, in words. Now we come to the one that gave people the most problems. The reason this problem is on here is, and I've explained this to quite a few people, there was almost exactly the same problem in section 3, number 3 on the homework. And I referred a couple people back to that. So let's look at this. It says you find 2 pennies on the floor. Okay, so let's go from there. I don't know, is this growth? What's going on? Tomorrow you find twice that number, 4 pennies. Each day you double the money of pennies you found. You lucky dog. There's nothing in here that says anything about compound interest. You are growing in pennies. You are gaining pennies every day. And so for number 9, this is a growth. Some of you came up with your own formula. All we talked about was growth, decay, and compound interest. This was a growth. So y equals a 1 plus the rate to the time. Now part A asks you to create a function, which just means create an equation in function form to model this situation. So f of x equals, or f of t, if you would like, or you could say, let's go with f of t. Okay, our initial amount was 2 cents. Some of you forgot to put 0.02 and you just put 2. That's going to make a difference. Our 1 just tells us we're going to always add back to what we had the day before. 100% of what we had the day before, we get back again. Our rate, this is what threw most people off. If we're doubling something, we are taking 200% of what we originally had. And so our rate here was 200%. So we have to change that to a decimal, and the decimal is 2. And then we're going to raise it to some time. Part A doesn't give us a time, and so we leave it there. Part B does give us a time. They want to know at the end of 10 days, so I'm going to change t to 10. How much money do I have? Now again, this is calculator work, but I should have at least seen this equation written down. And then when you put this into your calculator, again, we're talking about money, so you should have rounded it. On day 10, you should have $1,180.98. Okay? Part C says at this rate, how much would you have after 30 days? Using the same equation, except this time we're going to go 30 days. Now this went up really high, and there was somebody that didn't actually believe this was true. So they started figuring it out using a table. I think they actually did all 30 days and they figured out this actually works. If you're doubling every day and adding to what you had the day before. Okay, $30 every day, 30 days. You end up with, let's see what the whole number is, because I rounded it on my answer key. So you get 0.02 parenthesis 1 plus 2 close parenthesis raised to the 30th. And you got 4.117822642 E12. Well, if you watch my videos, I explained to you what E12 means. And so leaving it at E12 is not a correct answer. All you're doing is copying from the calculator, so you really didn't know what you were doing. You should have done 4.117822642 times 10 to the 12th. Now, I didn't say you couldn't round it, so you could have rounded it if you wanted to, which is what I did. Some people did. But then the final answer means if this is in scientific notation, that means we have to move that decimal 12 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's really 4, 1, 1, 7, 8, 2, 2, 6, 4, 2, and then 3 zeros. Let's see if I have this correct. Okay. Oh, did I do 1 too many zeros? Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nope. Okay. And that's what it should have been. It was really huge. But I also taught you on the video, if you watched it, how to change an E12 into scientific notation. All right, let's do the last one, number 10. Number 10 says, Blake's trying to decide between 2 investing accounts. Plan A offers a monthly compounded interest. As soon as you see monthly compounded interest, you know you're going with A, P, 1 plus R over N raised to the N times T. Now, if you don't know what those letters stand for, you could have just gone back to your notebook and looked it up. If you didn't take notes, you could have gone back to my videos and listened and figured out what they were. So I made two different plan columns. I did plan A, and then I did plan B. Okay? In plan A, I did A equals, what's my principal? My original amount that this guy invests. Okay? He's investing it. That was a key word. Some of you messed that up. Was $10,000. Well, I'm going to need more room. Let me fix this. Okay, 1 plus the rate. The rate for the plan A was 0.75%. You still needed to change that to a decimal. So it really should have been 0.0075. And that was compounded monthly. So our N is 12. And then that would have been raised to the 12th power, and then he said he invested it for 5 years, times 5. I'm not going to have enough room, so let me take plan B down here. Okay, so plan A, when you put that into your calculator, your investment would have been about $10,382, and that's it. Okay, and then you could have rounded that. So that's my first plan. Plan B was the same thing, except we're going to change a couple things. He still invested $10,000. We still are going to get 100% of that compounded. His interest